Hi guys, welcome back to a new tutorial this year. Today I'm going to go over the 2019 3.4 mechanics for level 3 physics. So let's just get straight into it. So you probably won't be watching this until the externals or maybe derived grade exams, but I'm just making these videos in advance as I won't have as much time later on in the term. So question 1, rollerblading. So straight away I can see it's going to be a 2D momentum question, and part A, state a relevant physical quantity that is conserved during a collision. So the key word there is collision. Okay, so basically it's going to be momentum, right? Easy peasy. And if you want to be more specific, it's linear momentum, not angular momentum, but we'll get onto that later on. Or you could talk about, so you don't have to have this as well, the velocity of the center of mass and the energy. Of these three answers and you will be getting an achieved. Part B, at one instant, Ellie stops and Chris collides, blah blah blah, they move off. Show that Ellie's speed after the collision is 1.71, so again, still related to this momentum concept. We can see that, so what we should do first is find the initial momentums of both Ellie and Chris. So I know PIC, so PI of Chris is equal to M Chris and V Chris. So mass of Chris and velocity of Chris. So that's going to equal, we've got it here, so 60 times 1.8. And that's going to equal 108. Now, Ellie has no velocity before, so I know her initial momentum is going to be 0. Because anything times 0 is 0. So we don't need to waste time finding that. So, once we've found our initial momentum, we can use the conservation of momentum law. So, let's draw our vector diagram first. Initial of Chris. So that's going to be a big arrow facing forward, right? That's P.I. Chris. Then we've got Chris's, if I scroll back up, Chris's momentum afterwards. It's pointing upwards, that direction. So this is P.F. Chris. And then we've obviously got Ellie's momentum direction. So that's P.F. Ellie. And our right angle is up here. So that means this is the CAB. So we do have to use a bit of Pythagoras to find the momentum of Ellie. PF of Ellie is going to equal the square root, so it's always the square root, of Chris's initial momentum minus the momentum of Chris after. Which I haven't found yet, sorry, but I can do that now. P.F. Chris equals MV still, which is equal to his mass 60 times 1.1, which comes from here, okay? And that is going to equal 66 kg. Right, so now that we've found that as well, PFLE equals the square root of 108 squared, sorry, there should be a squared here and a squared here, minus 66 squared. So PFLE is going to equal, should be something like 85.486, da-da-da-da-da. So we've found the momentum, that's P. So we know P equals mv, so the velocity rearranged is just P over mass. Plugging in 85.486 divided by Ellie's mass, which is 50 kgs, it's there. And you should get an answer of 1.79 keeps going, so you're going to round it to 1.71 meters per second because of three significant figures here, okay? And also it says show, so we've proven that it equals 1.71. So this is a merit question. So merit is awarded if you can prove that Ellie's velocity is 1.71. To get achieved, you can either calculate Chris's momentum before, or the total momentum before, or calculate Ellie's velocity with an incorrect momentum. So you must have gotten to the 1.71 with another invalid method. So let's just say maybe even achieved is here. So even just this line is enough for achieved. Okay. To save himself from falling, Chris sees a horizontal bar and grabs it. Yada yada. Calculate the minimum speed Chris's center of mass will need to have at the top of the vertical circle in order to swing up and over the bar. So, anytime you're trying to find the minimum speed within a circle, well, there's two ways you can do this, but I prefer this way. So first of all, you would equate the centripetal force to the gravitational force, because at the top, right, the gravitational force completely supplies the centripetal force because they're both going in the same direction, right? So that's why we can make this assumption at the top. We can't make it at the bottom though, because gravity is going in the opposite way. Because remember, the centripetal force always points towards the center. So we can write out the formulas, which is mv squared over r equals mg. Please don't get confused. Do not do this formula, right? That's for orbits. Okay, we're not dealing with those type of questions, so do not equate it to that. So we're just going to use the standard gravity force formula. So we have to rearrange for the velocity, so we're going to just do some simple algebra. So we're going to cancel v squared over r equals g. I'm going to bring r to the other side, so we're going to multiply by r. So v squared equals gr. So v equals the square root of gr. So velocity equals the square root of g, which is on your formula sheet. It's 9.81 times the radius, which they would have given us. Yep, that's right here, 0.7 meters, and it's in the correct unit for us already. And that is going to equal 2.62 meters per second. So that's a very easy merit question. So merit is here. Correct answer 2.62, and with the correct working. Achieved is if you attempt to calculate the speed correctly but with incorrect FG or FC at top minimum speed. Okay, so even this is enough for an achieved, just having that correct assumption. Or right, last one. Describe and explain the size and direction. So it's really important we answer both aspects of the tension and weight forces at the bottom and top. So I'm just circling all the parts that I'll need to talk about. Assuming Chris swings over the top at the minimum speed, which we found before. Include force labels on the diagram below to support your answer. So let's just start drawing all our forces first before we do anything. So the first most obvious thing, I'm going to use different colors here to make it clearer, is there's going to be an FG, the gravity force at both ends, right? And they are going to be the same size plus direction. Okay, it's always downwards and it's always the same size of 9.81. So we've done the weight forces. Now the tension force. At the top, there's going to be no tension force. Alright? tension force equals 0. That's because all the centripetal force, so all the centripetal force is provided by the weight force, gravity, because, you know, it's going in the same direction. However, at the bottom, there will be a tension force, and this tension force is going to be large because it has to overcome the gravity force that's pulling it away from the center, and it has to provide the centripetal force, alright? So I'm going to draw my tension force like this. Tension. And make sure it is larger. Okay, that's very important. So we've sort of done that, and I've also explained it while I've drawn my forces, but I can write it out. So I'm just going to pause it and write it out. Okay, so I've written down the 3 main bullet points that you need to include within your answer that links with, you know, what you've drawn. So the first bullet point is the weight force is fixed or constant and always downwards at all positions in Chris's motion. Okay, so you can see I've drawn that. It's always downwards, there and there, and it's the same size. At the bottom, the tension is upwards and much larger than the weight force, Fg, as it must tension is up, as it must overcome the gravity force, to provide the upwards centripetal force. So we've drawn that on our diagram. And at the top, tension is 0 because Fc is completely provided by the gravity force. Since Chris is at the minimum speed, which is this equation that we also used up here, so you can see there's that link between the two questions. So if you don't know what to do, sometimes it's a good idea to look at previous questions for hints. So this is an excellence question. If you have all 3 points plus correct diagrams, you get an excellence. You could even get an E minus. E minus, that's if you don't have the diagrams. Merit is tension force drawn or described, so here or here, and achieved is any point. Right, so that's going to be it for question 1 of 2019. As usual, any questions, just leave a comment. And yeah, cheers.